Honors Chemistry Section 19.2 lesson video. And as always, if you want all my videos in one place, just subscribe and you'll have them for the whole year. Alright, so section 19.2 is on calculating hydrogen ion concentration, hydroxide ion concentration, pH, and pOH. And they all kind of work together, and I'll show you a version that I call the pH square on how to do all the calculations. So let's go ahead and get started. So the reaction in which water molecules produce ions is called self-ionization of water. So what happens is when you have a sample of water, most of the molecules are going to remain as H2O. But some of them will break apart into H plus and OH minus, and when one of those H pluses hits another water molecule, it'll turn into an H3O plus. So you could write this reaction as 2H2O yields H3O plus OH minus. But what I want you to notice is in the sample, there are very few that have actually broken up. Okay, most of them are going to remain as H2O molecules. So in an aqueous solution, your concentrations are represented by anything in brackets. So anytime you see something in brackets, that means concentration, which means molarity. So when your concentration of H plus increases, the concentration of OH minus must decrease and vice versa. So you can't increase both of them. If one goes up, the other goes down. However, and that's because the product of the two always has to equal 1 times 10 to the negative 14, and that value is referred to as Kw. W, of course, stands for water, and it's the ion product constant for water. So here's our first formula for doing calculations. So your concentration of H plus times your concentration of OH minus must always equal 1 times 10 to the negative 14. So that means if this number increases, then OH would have to decrease to still make that same product. And then K values have no units, so that's why the 1 times 10 to the 14 is unitless. So in a neutral solution, your concentration of H plus and OH minus are equal, and they'll both be 1 times 10 to the negative 7 molar. In an acidic solution, the H plus concentration is larger than OH minus, and in basic, the OH minus concentration is larger than H plus. If you remember back into the section 1 video, we said areneous acids produce H plus in solution and areneous bases produce OH minus in solution. So if your H plus is higher, that means there's more acid. If your OH minus is higher, that means it's more basic. So let's look at a calculation. So it says if the H plus concentration in a Coke is 1 times 10 to the negative 5 molar, what is the OH minus concentration? It is the solution, acidic, basic, or neutral. Okay, so we know our formula is H plus times OH minus equals 1 times 10 to the negative 14. So if I'm solving for OH minus, I would of course divide both sides by H plus. And so see, then that would cancel. So my OH minus is 1 times 10 to the negative 14 divided by my H plus, which is 1 times 10 to the negative 5. Now, a lot of you, the calculators that you use and the way you type the numbers into the calculator, you need to put your bottom number in parentheses. Now, of course, some calculators and the way you type it in can mean you don't need parentheses, but when in doubt, put parentheses just to make sure. All right, and so then, of course, when we solve that, I ended up getting 1 times 10 to the negative 9. And then our unit for concentration, if you're solving for H plus or OH minus, is always molarity. I know it appears that it's going to be 1 over molarity, but acid-base math is where units kind of get a little weird and they don't always just cancel nicely the way they do in the rest of science. Alright, so this is my molarity. So that's my concentration of OH minus. But then it says, is the solution acidic, basic, or neutral? So to tell, we just need to compare. Well, which one's bigger, H plus or OH minus? This is where you got to be careful though. You really only need to compare the powers. The only time you need to look at the front number is if the powers are the same, and then you'll look at the front number. So we have a 10 to the negative 5 and a 10 to the negative 9. You're going to have to be careful because we're dealing with negative numbers. So if you're having trouble figuring out which one's bigger, just draw a number line, and the number closest to 0 is the bigger one. So what's bigger, 10 to the negative 9 or 10 to the negative 5? Well, 10 to the negative 5 is bigger. And 10 to the negative 5 is our H plus. So if H plus is bigger, it is acidic. And so a lot of you, what you'll do is you'll say, oh, well, I had to find OH minus, so it must be basic. That's not the way it works. It's not about which one you had to find. It's about who is bigger, H plus or OH minus. If OH minus had been bigger, then I would have written basic. If they had been equal, then I would have written neutral. All right? So why don't you try the next one? So pause it, try it, and of course we'll try it together. So it says calculate the OH minus of a solution that has H plus of 6 times 10 to the negative 10 molar, and is it acidic, basic, or neutral? So remember, we have H plus times OH minus equals 1 times 10 to the negative 14. I'm trying to find OH, so I'm going to divide both sides by H plus again. Hopefully you're okay at rearranging. Whoops, sorry, my brackets kind of get crazy after a while. So then I just plug in. So my OH minus is 1 times 10 to the negative 14 divided by my H plus, which I'm going to put in parentheses. So it's 6 times 10 to the negative 10 molar. And so once I plug that in, I got 1.67 times 10 to the negative 5. And then of course my unit for concentration is molarity. So there's my answer, but of course I need to say, is it acidic, basic, or neutral? So if we look, we have a 10 to the negative 5 and we have a 10 to the negative 10. 10 to the negative 5 is bigger. So 10 to the negative 5 goes with OH, because we calculated OH. You were given H plus. So since OH is bigger, this would be basic. Okay, and so that's the way you do it. A lot of you'll get the number. It's that acidic or basic that's hard for you to figure out. All right, so again, try this one, pause the video, try it, and then we'll look at it together. So it says calculate the H plus concentration of a solution that has an OH minus of 3 times 10 to the negative 2 molar. Is it acidic, basic, or neutral? So again, I'm going to start with my original formula. All right, and we're solving for H plus this time. So I'm just going to divide both sides by OH minus. So then I just plug in. So it's 1 times 10 to the negative 14 divided by my OH minus, which is 3 times 10 to the negative 2 molar. I'm going to put that bottom number in parentheses, and then when I solve, I got 3.33 times 10 to the negative 13, and my unit for H plus, of course, is molarity. So last step, we got to determine, is it acidic, basic, or neutral? All right, well, I have a 10 to the negative 13, and I have a 10 to the negative 2. So which is bigger? 10 to the negative 2 is bigger. So what does 10 to the negative 2 go with? OH minus. So if OH minus is bigger, then it is basic. Okay, remember, H plus indicates acidic, OH minus indicates basic when we're talking about which one is more. All right, so hopefully you got both of those, or at least one of those, right? So let's look at some more formulas. So this is the formula you use to get between H plus concentration and OH minus concentration. So the next thing we have to talk about is pH. So most people have heard of pH scale when they come to my class, and have even used like the little litmus paper or the pH strips to see the color changes, but a lot of you haven't done the calculations. So the pH of a solution is the negative log of the hydrogen ion concentration. So here is another formula for us to use. pH equals negative log of H plus. Now, pH scale, anything less than 7 is acidic, exactly 7 is neutral, and anything greater than 7 is basic. And then pH has no units. I know that's weird because I'm a units person and I'm always like, oh my gosh, don't forget your units. But pH actually has no units. But if you put units, I will then mark half off. So no units for pH. So let's look at an example of a pH problem. So it says, what is the pH of a solution with a hydrogen ion concentration of 4.2 times 10 to the negative 10 molar, and is it acidic, basic, or neutral? Okay, so we know, well, pH equals negative log of H plus, so I just plug into that formula. Negative log of 4.2 times 10 to the negative 10. And so when I plug in, I got 9.38. Now again, pH has no units, so notice I did not put any units. Remember, H plus and OH minus both have molarity. pH has no units. And so then now pH is greater than 7. So remember, less than 7 is acidic, 7 is neutral, greater than 7 is basic. Okay, so if you know pH, you just use pH. Don't even bother looking at the H+. That makes it harder to figure it out. Alright, so hopefully pH isn't that bad. These are pretty easy. And don't worry about the logs. Like, we're not going to change the base or do natural logs or anything like that. You're just pressing a button in the calculator. Alright, so maybe pause it, try these, and then we'll look at them together. So it says, what is the pH of a solution that has an H+ of 0.0015 molar, and is it acidic, basic, or neutral? So pH equals negative log of H+. So I just do negative log of 0.0015. And so when I solve, I got 2.82. So again, no units. And this time pH is less than 7, so it is acidic. Alright, if you didn't try that one on your own, try this one on your own. Remember, you got to be able to do them on your own. Alright, and then we'll look at it together. So it says, what is the pH of a solution with an H+ of 1 times 10 to the negative 12 molar, and is the solution acidic, basic, or neutral? So again, pH equals negative log of H+. So I'm just going to do negative log of 1 times 10 to the negative 12. And that's, of course, going to give me 12. Again, pH has no units, so I'm leaving it unitless. And if pH is greater than 7, it is basic. Alright, so again, hopefully you got one or more of those right. So let's look at some other formulas, and then we'll do a little more practice. So most people have heard of pH scale when they come to my class, but not everybody is really familiar with pOH scale, but as you can imagine, it's just the complete opposite. So pH scale measures the H+ concentration, pOH scale measures OH- concentration. And since H+ and OH- are opposites, the scales are opposite. So here's our formula, pOH equals negative log of OH-. Now on pH scale, less than 7 is acidic. So on pOH scale, less than 7 is basic. Now 7 is still neutral, but on pH scale, more than 7 is basic. On pOH scale, greater than 7 is acidic. And pOH, just like pH, has no units. Alright, so pOH and pH, like I said, they're just opposites. So if you overlap them together, it'll look like this. So let's say something has a pOH of 3. That means pH is 11. Well, 11 plus 3 is 14. Let's say something has a pOH of 8. That means pH is 6. 8 plus 6 is 14. Every time you add them, you will get 14. So the way you get in between pH and pOH, like say I give you pOH but we need pH, is you just use this formula. pH plus pOH always equals 14. So the last two formulas we have to look at before we try some more. So we know how to get between H+ and OH- using the 1 times 10 to the negative 14. We know how to get between pH and pOH using pH plus pOH equals 14. And we know how to get from H+ or OH- down to pH or pOH by using negative log. Well, how do we go backwards? What is the inverse of log? Well, for those of you who do have a little bit of trouble with that, you just do 10 raised to the power. Okay, so if you have pH but you want H+, or you have pOH and you want OH-, you just do 10 to the negative pH, and that'll give you H+, or 10 to the negative pOH, and that gives you OH-. So this is not 10 minus pH, this is 10 raised to the negative pH power, or 10 raised to the negative pOH power. Alright, so let's look at a couple more problems. So this right here is what is called the pH square. I gave y'all one in class, but don't get used to using it because you can't use it on the test or quiz. But it just shows you where you're starting and where you're going to. Because it's a square, the longest problem I can give you is 2 steps. Okay, because if I give you H+ and ask you pOH, that would mean you would have to either go across and then down, which would be 2 steps, or you could go down and then across, which would be 2 steps. Both ways will give you the same answer. I recommend you go down and across the bottom because this is the formula that y'all have the hardest time putting in the calculator correctly. So if I ever give you 2 steps, like if I give you from here to here, I would always go down and across the bottom. Try to stay away from that formula just because, like I said, a lot of y'all have trouble putting in the calculator correctly. So let's look at one together. So it says the pH of an unknown solution is 6.35. So in other words, we know pH. What is the hydrogen ion concentration? So that means we're looking for H+. Okay, well we know the formula says pH equals negative log H+, but we know pH, so we need to use that inverse formula. And that was H+ equals 10 to the negative pH. That was on the previous slide. So then I would say, okay, well 10 to the negative 6.35, and remember that's not subtracting, that's raising it to a negative power. Once I do that, I get, if I could turn the page, I'll tell you what I got. I got 4.47 times 10 to the negative 7. Now, I did not give you a unit because I gave you pH, which is unitless. However, whenever you solve for concentration of H+ or OH-, the unit is always molarity. So you're going to have to remember to put that molarity there. Like nothing I give you is going to make you think molarity. So then it says, is it acidic, basic, or neutral? Well, remember, you don't have to look at your answer. You could look at what I gave you in the problem to tell us. So what's easier to look at, H+ or pH? Well, pH is usually what's just the easiest for you to look at. So since pH is less than 7, I mean it's a little bit less than 7, it would be slightly acidic. Alright, and so you just got to use your formulas to get from where I'm starting to what I'm asking for. That's all you have to do. And make sure you remember when to put units. If you're solving for concentration of H+ or OH-, you need the unit molarity. If you're solving for pH or POH, no units necessary. Alright, so pause this one, try it, and then we'll look at it together. So it says calculate the pH of a solution with a POH of 12.17, and is it acidic, basic, or neutral? Well, if you remember, our formula to get between pH and POH was pH plus POH equals 14. So I'm looking for pH, so I'm going to subtract POH from both sides. So pH equals 14 minus POH, which is 12.17. And so once I subtract that, I got 11, whoop, I did not get 11.83. I'm clearly looking at the wrong one. I got 1.83. Alright, and so if I get 1.83, and this is my pH, so see that's where you have to be careful, is are we on the pH scale or the POH scale? So I got a pH of 1.83, which is less than 7, and it has no units. That would be acidic. Now let's say instead you're like, well, what if I wanted to look at POH? Well, you can. If POH is greater than 7, then it is also acidic. So it doesn't matter which number you look at, because remember they're opposites. Alright, so hopefully you got that right. Try the bottom one. I'll give you a hint. It's a two-step. Try the bottom one, and then we'll look at it together. So it says, what is the pH of a solution if OH- is 4 times 10 to the negative 11 molar, and is it acidic, basic, or neutral? Alright, so remember we have two options of how to go. I'm going to pick one pathway, but if you went the other pathway, that's fine. You should still get the same answer. So the first thing I'm going to do is I'm going to say, okay, well I have OH-, I want to try to get to POH. So if you remember, our formula says POH equals negative log of OH-. And so that's what I'm going to plug in first. So I'm going to do negative log of 4 times 10 to the negative 11. And so once I solve that, I got 10.4. And remember, pH and POH have no units. That's why I dropped the molarity. But this right here is POH. I asked for pH. Well, then I can just do my formula like this up here to get between pH and POH. So we know pH plus POH equals 14. So I have POH, I'm looking for pH, so it would be 14 minus POH. So then I would just do 14 minus 10.4, and that's going to give me 3.6. And remember, pH and POH have no units, so that's why I have none here. Now remember, you can look at POH to tell acidic, basic, or neutral, or you can look at pH. It doesn't make any difference. I'm going to look at pH. It's less than 7, so it's acidic. However, POH is more than 7, so it's still acidic. Okay, it doesn't matter which one you look at. Just make sure you know which scale you're supposed to be looking at. Alright, and the two-step, that's the hardest it can get. It can't get any harder than a two-step because you got to think it's a square. If you think you need to go 3 steps, you could have just gone 1. Alright, So let's move on. So the last thing we just have to talk about is an acid-base indicator. So an acid-base indicator is a special chemical that changes color as the pH of a solution changes. So you can see here are a bunch of different acid-base indicators. It's going from a pH of 1 to 10. And so you can see how the color changes as you go through. The favorite indicator for titrations usually is phenolphthalein, because if you look, there is an absolute color change. It's either clear or it's pink. For some of the other ones, like see how there's different shades, and so then it's like, okay, well when did it officially turn from pink to purple? Or when is it kind of still a pinky purple? So that's why phenolphthalein is one of the choice ones for titrations. Also because it changes in the correct pH range. So let's do the section assessment. So what is the relationship between H plus and OH minus in aqueous solution? Well, remember, for H plus and OH minus, if one goes up, the other goes down. So we can say they're inversely proportional. Alright, number 2, it says, what is true about the relative concentrations of hydrogen ions and hydroxide ions in each kind of solution? So in basic, what would be bigger, H plus or OH minus? Well, in basic, bases produce OH minus. So OH minus concentration would be greater than H plus concentration. Alright, acidic would be the exact opposite. Acids produce H plus. So in an acidic solution, your H plus will be greater than your OH minus. And then of course neutral, they have to cancel each other out. So that's when your H plus equals your OH minus. Alright, so number 3, it says determine the pH of each solution. Now I'm going to go out of order. I'm going to do A, C, and then B and D because they give me the same thing for A and C. They give me H plus to start with, and then they give me the same thing for B and D. So that way I can do 2 similar ones. So for A and C, I have H plus, I need pH. So what's my formula? Well, for A and C, I'm going to use the formula pH equals negative log of H plus. And so if I plug in H plus, I will get pH. So let's go ahead and do it. So pH equals negative log of 1 times 10 to the negative 6. Ooh, I'm running out of room. I hope y'all can read that. And so what that will give me is 6. So my pH for part A is 6. I have a little more room over here. So here we have pH equals negative log of 0.0001. So that's going to give me a pH of 4. Alright, and so again, you're just plugging in the calculator, negative log, and then your number. Negative log, and then your number, just over and over and over again. Alright, so let's look at our next one. So B and D, they give me OH minus. So we're going to follow that pathway we did just a second ago. It's going to be a 2-step. Because the first thing I'm going to do is I'm going to try to find POH. So POH is negative log of OH minus. That'll give me POH, but of course I've asked for pH. So since we already rearranged the formula, I'm not going to do it again. But if you remember, pH equals 14 minus POH. That's just me rearranging the pH plus POH equals 14 equation. So I'm just going to follow these 2 steps for each of these because OH minus to pH takes 2 steps. So first I'll do my POH equals negative log of 1 times 10 to the negative 2. And that's going to give me 2. That's my POH. So then I'm going to plug into pH is 14 minus 2, which means my pH is actually 12. Okay, so you just got to be careful for what you're given and what you're looking for. Because it's really easy to accidentally just do negative log and then assume you've made it to pH. Alright, so I'm going to do the same 2 steps over here. So first I'm going to do POH is negative log of 1 times 10 to the negative 11. That's going to give me 11. That's my POH. So then I'm going to use my bottom formula, pH equals 14 minus 11, which of course is 3. Now the reason I'm getting nice whole numbers for all of these, you may be wondering why, is because all of these are based off of 1. Like the front number of the scientific notation is just a 1. When it is a 1, you do end up with a whole number. If this was like a 2.7 times 10 to the negative 11, that's when you'll start getting decimal places. Alright, so let's click and look at our last one. right, so it says, what are the hydroxide ion concentrations for solutions with the following pH values? So again, these are going to be 2 steps because we know pH, we're trying to get to hydroxide ion concentration. So first, if I was thinking, okay, well I have pH, I'm trying to get the hydroxide ion, I would use my POH equals 14 minus pH. That was just me rearranging the formula, by the way. I would use that first to get POH, and then once I have POH, I can say, okay, well OH minus is 10 to the negative POH. So it's just about picking the right formulas for each problem. Alright, so I'm just going to use each of these steps for all 3 of these. Alright, so POH is 14 minus 6, which of course is 8. So that gave me POH. Well, then I can plug in. So OH minus is 10 to the negative 8, which if you put that in the calculator, because this is a whole number, it's just going to give you 1 times 10 to the negative 8. And then what are the units for concentration? Molarity. So see, even though none of mine have units, that's because I gave you pH values, which have no units. But if you calculate concentration, you have to use molarity. So now do the same thing here. So POH is 14 minus 9, which of course is 5. And so then OH minus is 10 to the negative 5, which if you put that in the calculator, it'll most likely just give you 1 times 10 to the negative 5. So if you left it as 10 to the negative 8 or 10 to the negative 5, I would mark it right as long as you remember to put molarity. Alright, and so then last one, number 12. So we have POH equals 14 minus 12, which of course is 2. So then my OH minus would be 10 to the negative 2. And if you put that in the calculator, most likely it's going to give you decimal form. So you'll probably get this right here. And then don't forget your units, which are molarity. Okay, so the important thing is when you're learning the pH square, maybe in the beginning, like use the square, work your way through it, figure out which formula to use when. They've been rearranged for you, so that helps. But then as you get used to practicing, then stop using the pH square. Because you're going to have this memorized. Like, you're not going to get this on the test or the quiz. So, like I said, practice with it first, and then just kind of wean yourself off of it. But hopefully, now you know how to use the pH square.